When you think of evolution, what comes to mind? Maybe the tree of life showing different animals branching from common ancestors over hundreds of millions of years. Maybe you think of the first amphibians that crawled out of the water onto the land and started breathing air. Or the little mammals that survived the extinction of the dinosaurs. Maybe you feel a kinship with the plants and animals. Maybe you think of our relationship to monkeys and feel a little disgusted by it. Or maybe you think of DNA and the double helix, swapping out base pairs so that generations down the line can adapt to new circumstances. Today, we'll talk about how evolution works, but also how it can be applied to other systems such as culture, markets, technology, and more. Living beings have DNA, which is grouped into genes which determine their phenotypical traits. How their bodies are built, their bodily processes, having hands, eyes, and a heart are phenotypical traits. The instincts to survive, eat, and socialize are phenotypical traits. The elements of DNA are called nucleotides. There are 4 of them, each which start with the letters C, G, A, and T. Because DNA is a double strand, they come in pairs, C with G and A with T. So we call them base pairs, which is much easier to remember than nucleotides. Every generation, the parent's DNA is copied and spliced together to make the DNA of the next generation. This new DNA has a few mutations, changes in base pairs due to copying errors or outside factors. Mutations change the code of the DNA and therefore affect the genes and phenotypical traits of the organisms. The probability any single base pair will mutate is about 1 in 100 million. So for humans with a 10 billion base pair DNA sequence, that comes down to about 100 mutations per child. However, these mutations are random. Some cause traits that make it easier to survive and reproduce, some are negative, and some are neutral. The ones that are better at surviving survive better. No crap. And their mutations spread and become common, while the negative mutations disappear. This is called natural selection. There isn't any single direction of more evolved or less evolved. Instead, the direction a species evolves is determined by selection pressures in the environment, such as their food source, the behavior of predators, what biome they live in, minerals and chemicals in the water. Species live in ecological niches. When the environment changes, the usefulness of traits for survival changes, and natural selection causes the species to adapt. Evolution by mutation and natural selection is slow. It can take thousands of generations for significant changes to build up. But that's not the end of the story. There's also epigenetics. As it turns out, genes can be turned on and off by processes inside the cells, changing the organism's phenotypical traits. These changes are passed down to the next generation. Evolution by epigenetics can have noticeable changes over single generations. There's a trade-off though. Epigenetics cannot create new DNA, so although it can cause quick adaptation, it's limited by the genes the organism already has. On the other hand, mutation and natural selection may be very slow, but it has no limit. That's biological evolution in a nutshell. It has 3 major elements: a replicating code, an environment with selection pressures, and a phenotype, traits caused by the code that interact with the environment. There's nothing saying this only applies to biology. Culture, for instance, is also an evolutionary system, and instead of genes, its replicating code is memes. No, really!
Memes, the DNA of the soul.
When we think of memes, we think of pictures on the internet with captions. But those are just one type of meme. Catchy tunes, fashions, ideas, quotes, stories, and values are also memes in the sense of memetics, abstract things that spread by human psychology. The ways we view and relate to the world, our beliefs, our religious and political views, social norms, what's popular, all these are made of memes, and they thrive or fade away based on the selection pressures in the ecosystem of human psychology and interaction. In this way, things like trends, religions, ideologies, and traditions are like organisms living in symbiosis with us. Well, technically because they require human beings to reproduce, Viruses would be more accurate. But that has connotations of being a disease, and memes can be positive, negative, or neutral. I would wager that you're more comfortable labeling a cult a virus and your own religious views a symbiont. Now that we're getting the idea, we can apply evolutionary logic to other things too. For instance, the market is an evolutionary landscape of supply, demand, regulation, taxes, and subsidies. Its organisms are businesses and people, and the DNA is people's abilities and their thought processes when they make decisions. The selection pressure is money. Those whose habits and choices lead to gaining money thrive, and those who don't, well, businesses crash and people go live with their parents. Engineering is an evolutionary landscape. Wait, hold on. Engineering? How can something that's about people designing stuff be evolutionary? Because it has variation, selection pressures, and expression. When an engineer designs a product, they use tried and true techniques. The ones that were tried and failed aren't used. The engineer runs simulations and makes prototypes, tweaking each iteration for better efficiency. The ones that perform their intended purpose survive, the selection pressures being marketability and the laws of physics and chemistry. See? Evolutionary. You might be wondering how we can tell the difference between natural evolution and evolution by design. Here are some key differences. Design is sensibly efficient. There's a logic to the way it's constructed as opposed to other ways. Design is most likely modular. That is, you can take out parts and swap in new ones rather easily. Its function is the intention of the designer, and more often than not, it is designed to be comprehensible by humans. Evolution adapts structures to new situations, so it's messy in its efficiency. The go-to example is the recurrent laryngeal nerve, which goes from the brainstem down the neck, loops around the primary artery, and comes back up to the vocal cords. This made sense in our fish ancestors where it was just a straight shot. But as heads slowly grew separate from torsos over millions of years, it was easier for evolution to make that nerve just a little bit longer rather than reroute it entirely. It's not as easy to swap out parts because they're more often integrated into multiple systems. It leaves behind vestigial parts, which had more or different functions in the previous versions or ancestors than in the current generation. It selects functions for survival and propagation. And evolutionary systems tend to be harder for us to comprehend than things we design. With what we've learned today about evolutionary systems, we can recognize them playing out all around us, and we can find a lesson to apply to our own lives. Sometimes, in order to thrive in the future, we must let go of things in the past. Thanks for watching. I'll see you next time.